All right, I put my big girl pants on. We got to go ahead and take care of this one. All right, I got my lunch, but I'm like, no, just get it done with. All right, number 7. This is a review from Algebra 1. Absolutely a keystone tested item. Let's take a look. Small baskets of tomatoes. Oh, this is not a fun. I swear they make problems boring on purpose. A small basket of tomatoes are sold at a vegetable stand for $3 per basket. Oh, period. Oop. Large baskets of tomatoes are sold at the stand for $5 per basket. Period. Sorry. Only whole numbers of baskets may be purchased. Like you can't be like, oh, can I have a third of that basket? A customer purchases a total of 8 baskets and pays a total of $36. Write a system of equations. Oh my gosh, that sounds intimidating. That models the number of baskets X and the small and large basket Y. All right, guys. Unfortunately, this is not a y equals mx plus b formula because there's no beginning amount and no changing amount. Okay? So this problem, x is anything that has to do with small baskets. So small baskets I see are $3. So that is $3 for every small basket. Large baskets, I see they want that to be y. See that right there? Large baskets are y. Oh, wait, you don't know where I'm pointing. There you go. There it is. Large baskets are 5. So this particular equation has to deal with money. So it's the money for every small plus the money for every big has to equal the total amount of money that you spend, which in this case is $36. Now you might not see that as a y equals mx plus b. However, it is technically a y equals mx plus b if you solve for y. Now, there's a rule, right, in math that says if you have 2 variables, you have to have 2 equations. Well, I don't have 2 equations yet, do I? How about this 8? This 8 represents the small and the large together. So the small and the large. A lot of people don't see that equation. That is hard for kids to see, even into Algebra 2. All right, this is the system. That's what they asked about. Now we have to solve it. So I'm going to do a quick duplicate. Solving this, you can do it 3 different ways. You can set them equal to y and graph. However, actually, let me do that because it might be neat for you to see. Let's see, that would be negative 3/5 x plus 36 over 5. And that would be negative x plus 8. If you graphed them, you can surely see that they do cross right there-ish, right? But I'm going to, maybe you don't know how to do it that fast. I did a lot of math in my head right there. So most kids will see this using elimination, where you have a 1 here. So you take the 3 and you put it here, and you take the 1 and put it here. However, one of them needs to be negative. I'll make the 3 negative. Now we distribute. Boom, boom, and boom. You did this in chapter 6 with Miss Miles and Mr. Thomas. So distributing a 1, we've talked about, does absolutely nothing. Distributing a negative 3, though, boy, oh boy, does that change that. Negative 3x, negative 3y, negative 24. So now our 2 equations have been multiplied by a factor, and now it's time to do some elimination. Elimination is when you get one, usually the first, if you set it up my way, variable to cancel out. So 3 plus negative 3 is 0. 5 and negative, so now we add these. 5 and negative 3 is 2. 36 and negative 24 adds to 12. So it's like we're adding them together, eliminating the x's. Now you divide each side by 2, and you get y is 6. Now, if you notice over here on my graph, you can see that where they cross, sure enough, y is 6. Now let's do x. Now, where in the world do we go for x? Well, you can go anywhere. I would highly encourage you to use this equation here that I'm duplicating. Okay? The reason because it's easy. So take out the y, replace it with the 6, and now solve for x. So take away that 6 to get x by itself. X is 2. So you remember, y is the 6 large baskets, and x is the 2 small baskets. And look back over, and sure enough, they did indicate to us that small was x and large was y. And that's how a cute little review for you of Algebra 1.